Worked out examples, worked out problems. We are talking about D-MOSFET. Worked out problems. Problem 1. Which of the following statements is correct for MOSFET? P-channel MOS is easier to produce than N-channel MOS. N-channel MOS must have twice the area of P-channel MOS for the same on resistance. C. P-channel MOS has faster switching action than N-channel MOS. P-channel MOS has higher package density than N-channel MOS. These are the options. Which one of the following statement is correct? The option is P-channel MOS is easier than N-channel MOS. Option is A. So generally it is easy to make P-channel, but N-channel is preferred because mobility of N is greater than mobility of P. That is the answer. Problem 2. The measured transconductance of NMOS transistor operating in the linear region is plotted against gate voltage at a constant drain. Which one of the following represents the expected depends on GM on VG? Options are given A, B, C. So when you look at this, suppose this is VG, this is ID. This is the characteristics for FET. This is called transfer characteristics. But GM is equal to 2 times of IDSS by VP 1 minus VGS by VP. If you draw for GM, versus VG, how does the characteristics come? Characteristics will come as this. It is increasing and then falling. So this is option A. So this is transfer characteristics, but this is GM from this expression. Question number 3. The source body junction capacitance is approximately 2 pico, 7 picofarad, 2 nanofarad, 7 nanofarad. Let's see that. When we say capacitance, epsilon A by D, that is nothing but epsilon naught epsilon R L by D. Epsilon naught epsilon R L into W by D. Because area is L into W, therefore 8.854 into 10 power minus 12 into epsilon R of silicon dioxide layer into L into W by D. If you simplify, it will come order of picofarad. Suppose you take epsilon R of a silicon dioxide layer 11.7, L into W is, that means area 1 micrometer into 0.2 micrometer, and D is 10 millimeter, And if you substitute all, you will get 2 picofarads. Therefore, option is A. Question number 4. The gate source overlap capacitance is approximately given by options 0.7 picos, 0.7 nano, 0.35 nano, 0.25 pico. Let's see the option solution. C is epsilon A by D for gate. Epsilon naught, epsilon R, A by D. Epsilon silicon, L into W by D. If you substitute values, 8.854 10 power minus 12. Epsilon of gate material, you can take it as 3.9 into, suppose you take L, all the area as 10 power minus 14, this total is area, divided by D, distance. It will come approximately 0.7 picofarad. So therefore, option is A. Problem 5. Assert A. MOSFET perform very well in parallel operation. Reason: MOSFET has small turn off time. Options: as we know, this is assert and reason. We need to say both are true or false. If this is true, whether it is linked. Let's go to solution. MOSFET has very high frequency device, therefore perform well in a parallel operation. Therefore, A is true. Small turn of time has only majority carriers. MOSFET has small turn of time because it has only majority carriers. So, R is also true. But this is not the explanation of A. Therefore, option is B. Why it is B? Assert is true, reason is true. Reason is not the reason for A. When you look at the MOSFET or any FET for that matter, it has only majority carriers. When it has only majority, what will happen? Minority is not there. That means no turn off time. Turn off time is very less. Because when you say switching time is defined as storage time plus transit time. So this is for majority to minority. That's why this is not there, only transit time. Therefore, switching time of FET is very, very less compared to switching time of BJT. So, reason is true, assert is true, but R is not the reason for A. Therefore, option is B. Question number 6. Two MOSFETs M1 and M2 are connected in parallel to carry a total current of 20 amperes. The drain to source voltage of M1 is 2.5 volts and that of M2 is 3 volts. What are the drain currents of M1 and M2 when connected, sharing in series resistance of each 0.5 kilo ohms? A. 10.5 milli, 9.5 milli. B. 9.5 milli, 10.5 milli. C. 10.5 milli, 10.5 milli. D. 9.5, 9.5. Right? Let's see the solution. Take for example a MOSFET like this. This is a MOSFET we have. Take like this. They are connected in parallel. Say this is M1, M2, VDS1, VDS2, RD1, RD2, 0.5 kilo, 0.5 kilo, ID1, ID2. That's what he wanted to say. That's the approximate idea. Now what we can say, VDD minus VDS1 is, how much is said in the problem? 2.5. VDS2 is 3. So VDD minus 2.5 by 0.5 kilo plus VDD minus 3 by 0.5 kilo is equal to, he said total current is equal to 20 milliamperes. From here you solve for VDD 7.75 volt. So this is 7.75, 7.75, you will get 5.25. This is 4.75. So what are the values that you can say? 0.5 goes up and become 10.5. Kilo goes up and become milli. 9.5 milli. This is the answer. Therefore, coming to our options, our option is A. Problem number 7. This is a matching. Match the following: BJT, mass capacitor, laser, diode, and JFET. In the list 2, mass, population inverse, pinch off voltage, early effect, and flat band voltage. In matching, I'll take answers and then match the things. Say A, B, C, D. Okay, he said 3142. Second one he says 2143. C he says 3412. D he says 2413. Because in matching, whatever you know clearly, finish it off. For example, what we know in this list is list 1, list 2. A, B, C, D he said. First he says BJT. Second he says mass capacitor. Third he says laser. Fourth he says FET. In fact he says JFET. And 1, 2 he says population inversion. Second one he says pinch off voltage. Third one given to us is early effect. Fourth one given to us is flat band voltage. Flat band voltage. Now in matching, the best way is you see here and match it. Whatever you know, you find out. Remaining, you can guess it. The best thing we know, A is 3. Why? BJT has a link to early effect. The second thing that you know is D is pinch off. With these two, can you finish the answer? A is 3, so this is wrong. This is wrong. D is 2. 3, 2 is matching. Now there is a confusion between 1, 4. Because there are 4 things, at least 3 you must know. So let us check for one more answer. It seems to be A, it seems to be C, but we need to finalize the best one. For those 2, you have to identify what these 2 are. Okay. So when you say, if you know one of these 2, the best option you can go for is B, flat band voltage, that is called 4. Suppose B is 4. So what is B for? 3 we know. 3 is here, 3 is here, 2 is here, 2 is here. 4 is here. Therefore, our confirmed is C. That's why you have to say by elimination A can be true, C can be true. But finally, after checking all, the best answer is C. Like that, we can go by elimination and process. Problem number 8. The regions of operation of a MOSFET to work as a linear resistor and a linear amplifier. Linear resistor, linear amplifier. What regions of MOSFET? A, cutoff and saturation. B, triode and cutoff. C, triode and saturation. D, saturation and triode. The options are triode and cutoff. This is the options possible. What do you mean by triode? Look at the question that he is asking. He is asking for a MOSFET. He is saying MOSFET should act as linear resistor. Secondly, MOSFET should act as linear amplifier. So for this option, the triode region and the cutoff region is the correct. Therefore, our option is, the solution option is triode and C. It is given in B. That's the answer. Problem 9. Statement 1. MOSFETs are intrinsically faster than bipolar device. Let us write statement 1. MOSFET is fast than BJT. Statement 2. MOSFET has excessive minority carriers. Excessive minority carriers. Now, let us see the options he has given. I'll just give you and then discuss. First one, both are true. S1, S2 are true. S2 is the explanation of S1. S1 and S2 are true. S2 is not the explanation of S1. Here S1 is true, S2 is false. S1 is false, S2 is true. This is a general style. This is not a new style of writing. Only difference, he has been asking another questions are he is saying assert and reason. That's why these options are always standard. We don't need to even see the question paper. Options are same, but question will change. That is the style of question. That's called assert and reason. Because in IES, he has different styles. So this is given in IES. Let's go to the solution. Let me give you a small hint about solution. Generally, in MOSFET is faster than BJT. You know why? MOSFET has only majority carriers. Just like we discussed in the previous question. That's why definitely MOSFET is faster. So this statement is right. But MOSFET has excessive minority carriers is wrong. In fact, forget about excessive, there is no minority at all. Therefore, our solution is statement 1 is true, statement 2 is false. Therefore, our option is C. Worked out problems 10. Consider the following devices: BJT in CB mode, BJT in CE mode, JFET, MOSFET. The correct sequence of these devices in increasing order of their input impedance. IES 1999. Let me give you what he is exactly saying. BJT common base mode, BJT common emitter mode, third one is JFET, fourth one is MOSFET. Okay. Now I will give you the options also. The options that you have is, he said 1, 2, 3, 4, because better we take his options. 2, 1, 3, 4 and 2, 1, 4, 3, then finally 1, 3, 2, 4. These are the options. I will tell you one by one. First of all, this has highest input impedance because silicon dioxide layer. This has next input impedance because input is reverse bias. Therefore, the best way to go, the answers are, fourth one has the highest input impedance. This is the highest. Because silicon dioxide layer is acting as insulator, so highest input impedance. Third is the next because reverse bias. Therefore, Ri of MOSFET is greater than Ri of JFET. Now listen, that means this is 4. Input impedance increasing, he said. The increasing order of input impedance. So this is the highest, this is the next highest. Then what are the other things like that? The question is very simple. 4, 3, go in the reverse order. 4, 3, reverse order, 4, 3, 4, 3. Cancel this, cancel this. So I am teaching you how to choose these multiple options. Even if you don't know the concept well, you can manage. Because the best thing you know, this is highest, this is the next highest. So over. So but we are left with again trouble. It can be A, it can be B. Now I need to find the best answer again. The best answer, of course, common emitter is the next one. The least input impedance is common base. So that means this is second, this is 1. So in the increasing order, what is the increasing order? Smallest to highest, 1, 2, 3, therefore option is A. The option for this question is A.